All right, page 49. Okay, don't let the words confuse you. It's just the official terms we use in the unit, right? So dependent versus independent events. I will tell you this. Up until now, everything was independent. Nothing that happened affected what's coming next, right? But now, this is new, right? So this is what we're at today. This is a new concept, okay? We are now going to talk about dependent, but I'm going to compare them side by side so you understand the difference, okay? This is on 49. Independent events are events where the first, right? The first does not affect the second. So events where the first does not affect the second, right? So for example, if I roll the die here, I roll a 5. Does this outcome affect what I'm going to roll next? Not at all. These are independent events. And you know why? Because you're not removing an outcome. You're not removing, there's still always 6 outcomes every time. However, cards, right? Let's take the jokers out. If I just grab a random card and I grab a 6 of clubs, right? I put that aside. I don't put it back. And I want to draw another card. Is the probability going to change for my second draw? Yeah, because I removed a card. So the total number of outcomes has changed, right? So cards are notorious for being dependent. The key word is, though, whether or not you're putting this one back. So far, we were like, what's the probability of getting a 6 of clubs? Well, it was 1 out of 52, right? But if you put that back, if you replace it and draw another one, then it's not really a big deal that nothing has changed. You still have 52 unique outcomes, right? So that's the biggest difference today. That's what we're going to consider, okay? So if you draw a card, record your result, then replace it, right? We're replacing things. The total number of cards remains unchanged. That's why it remains independent. Rolling dice does not affect the total outcomes for a second roll, even a third, even a fourth, doesn't matter. You record results, you roll again. I will just total outcomes don't change. That's the big reason why we would call things independent, one event after the other. So obviously we're talking about multiple events, one happening after the other when this is the case. I'm going to use a different highlighter, maybe orange or something, for dependent now, right? Just to make sure we have a difference there. Is that blurry or is it just me? I feel like my eyes are going on me here. Okay, dependent events are dependent. When is that? When the first event affects the total number of outcomes for the second event. All right, the keyword you want to look for is, you see that right there, no replacement. It's not always going to say no replacement, it's just going to say, you know, a card is drawn and not put back, but that is saying no replacement. When cards, marbles, candies, etc. are not being returned, right? Not being returned, there it is again. After being drawn, it affects the total number of outcomes for the second draw. Your teacher picks random students to come to the front of the class, right? The chances of you being picked next increase since the number of students remaining, right, the total outcomes, is decreasing. So as students are being picked and you're still waiting, right, the chances of you being picked next are actually getting bigger and bigger because there's fewer remaining, right? So I hope that makes sense to you. Next, a bag of marbles has 3 red, 5 blue, and 2 green marbles. I purposely made it 10, right? Total is equal to 10, right? And look at that little bag there. Isn't that cute, right? Hand drawn, okay? With a mouse, of course. If a blue marble is chosen and not replaced, there's that word again. Not replaced. What's the probability of drawing a red marble next? Okay, so let's go and get rid of a blue here. You see this bag here? Scratch a blue. This one is gone now, right? So how many blues are left? There's 4. Sorry. Let's do the bottom one first. There's 10 minus 1, right? We're going to have 9 remaining at the bottom. The top, I messed that one up, sorry. What do we want? We want the probability of red. Let's make clear what we're doing here. Something already happened. A blue marble is chosen, not replaced. So obviously our total is affected. But is the number of red marbles, has that been affected by the first event? No, there's still 3 reds, right? 3 reds still remaining. So this would be 3 over 9. Can you reduce that? Yes, sir. 1 over 3, which would be 0.3333, which is 33.33%. So total has been affected. Therefore, this would be a dependent event. Just think about it. It depends, right? What happened before it affected it. So it's a dependent event. Next, if a blue marble is chosen and not replaced, dependent, right? Right there, you know it's dependent. Let's write it down right away. Therefore, dependent events. So if I ask you, hey, how do you know these events, like, are these independent or dependent? How do you know? Well, it obviously says things are not being replaced, therefore dependent. If things have been replaced, you would say independent, all right? You would say independent if things are being replaced. Okay? See. So we want probability of what? Drawing another blue one, right? So we want probability of blue. So we used to have 10, then we take out 1 because this happened already, right? This is first event. This is second event. This one right here. So obviously something happened before, so we got to take away 1. And watch this. We used to have 1, 2, 3, 4, 5 blue ones, right? But we actually took a blue one. So that is also being affected. Both are being affected here, numerator and denominator. Do you see that? Go to this pretty bag here and get rid of the blue one again, just like this. Right? So you're going to have a 4 and a 9, like that. We cannot reduce that, but we can turn that into a decimal. Look at that. 4, 4, 4, 4, pure coincidence. Okay. So sometimes both are affected. Sometimes just the denominator is affected, right? Total is affected, so I'll just say this. Total affected. don't know how to do this one. It's going to be too messy here. Numerator affected. If it's too messy, then try something different, but I just want to make sure. Maybe we'll highlight. I will use green maybe. I'll just highlight this one, right, that we got rid of, and that's the one here and there. Earlier, this one here, I'll use the same highlighter, just like that's the one we removed. It only affected the denominator there. Can you wrap your head around this? Yeah? All right. You know what? It will stick out like a sore thumb when this scenario happens, like things are not being replaced. Oh, okay, I know what's happening here. I just need to think a little bit, right? Watch this. If a red marble is chosen, this is your first event. Replaced. I'm going to use the highlighter that I used for independent events. If you have the same, go for it. Things are being replaced here. I'm going to say therefore independent events. Red marbles chosen, replaced. What's the probability of choosing another red marble? This is your second event. This is what we're really after, but we need to know what happened before, right? So probability of red we have 10. Nothing changed because we replaced it. We still have 10. And we just go look how many reds. There are 3 reds, right? That cannot be reduced. We're just going to go comma 0.3, which is 30%. Okay. Total not affected. Total not affected. So dependent, dependent, independent. All right. So we're gonna go back and forth between these, and this is the same with cards. It's the same with anything that I can possibly throw at you. Watch out. Is the first event affecting just the total? It's gonna affect the total for sure if things are not being replaced. The question is it also gonna affect the numerator, right? Okay, let's go to 50. I want you to try to answer all of these based on my very short lesson here. Okay? Put your knowledge to the test. 1, 2, 3, 4 questions. So I'll give you 4 to 5 minutes to do that. Okay? Remember, just give it a try. Give it a try and we'll correct it together. Right? I'm going to go over it. Green marble is drawn, right? Okay, that's first. What happens with it? Not returned. Dependent events. Right? I know something's going to change. I'm going to have to make some adjustments. So probability of drawing another green. Okay, so probability of green. I know I'm going to show this 10 minus 1, right? Because I'm getting rid of this green one here. And I used to have 2. I'm taking away the 1, right? So I'm 1 over 9 here. That's it. I asked you what this would be in odds, right? It'd be 1, 2, 8, right? It's 1, 2, 9 minus 1, 1 to 8 if I asked you for the odds. Again, a blue marble is chosen first, right? This is my first event. And then not replaced, dependent. I'm just going to go dependent there. What's the probability of a red? Oh, sorry. I threw an extra one in here, right? Careful. Then a green marble, right? So this is your second event. not replaced, what's the probability of a third draw being a red marble? Yikes, right? So probability of red now. First of all, I have 10 to start with. I take a 1 the first, I take a 1 the second. Okay, so let's go. That's why I did this here. You get rid of the green and a blue, right? So blue and green is gone. So there are 3 red still remaining. So in this case, only the denominator has been affected. So this would be 3 over 8, like that. Okay. So I will say this: first, second. And some of you don't need that, right? You get it. You just like, hey, it's 8. I have 8 left. But you know, if you go back in your notes later, it shows the work there. So if a red marble is chosen first, a green marble, that's my second, not replaced, so I know this is dependent. What's the probability of drawing? Isn't this the same question? My bad. Red, red, green, red. Apparently I need to read my own questions. Okay, probably a red here, 10 minus 1 minus 1. For red marble, I used to have 3, right? And the very first event was a red marble, so I need to take away that 1 that was taken, right? So you can go to our bag here and just get rid of the red and the green, because that happened, right? This happened. So I'm left with 2 reds and 8 marbles in total, which is 1 over 4, right? 1 in 4 chances of grabbing a red one on the third draw. I won't have a bag for you on the quiz, but this is just to show you, right? If a green marble is chosen first, right? First, another green one second. They're both returned. This is easy. When it's returned, then you go for it, right? What's the probability of a green marble in the third draw? Probability of green. I have 10, nothing changes. Just go find the 2 greens. It's 1 over 5, right? Done. 2 over 10 would be okay because I didn't ask it to reduce. So independent events, independent. The total does not change, right? I feel like I'm going to try this, right? The green, I'm going to try green here. So that's that second event. And the red, I'm going to use orange because I don't have a red highlighter, right? That's this one here and this one, right? So that this one, the red one, affected both the top and bottom there. Okay, this is it. Basically, this is the new concept that I wanted to cover today, or technically tomorrow, but things happen, right? Let's go to 51. I'm going to actually ask you for a little while. So remember, there's no AC today, so you just get to practice this without that pressure, right? So I'm going to ask you to go from 51 all the way to 53. Right? 51 all the way to 53. It doesn't take that long to answer probability questions, right? We're not solving a triangle or anything like that. You just have to be very careful of the numbers you put down. And look at that. I give you another deck of cards there. But you know what? I would suggest try to use your study sheet when you do these ones. Unless you really need this, try to answer this using your study sheet, or maybe just knowing what a deck of cards is comprised of. Okay? So give it a try. If you're quiet, you can consult with your neighbor. Okay. So you got to read carefully. Whatever happens in that initial statement, that stays. But then you you do not go A and then whatever happens in A comes with you in B. That's not true. You just always go back to the original statement, what happens there, and then you reset. Okay, so you draw a deck without replacing it, draws another one. And so I just give you the scenarios here, right? So don't draw A into B, right? Just leave it alone. Good question. You know why you take an extra pair of socks when you go golfing? Yeah, in case you get a hole in one. All right. So we do the draws a card from a deck of cards, and without replacing it, draws another card. So all of these events are dependent, right? We're probably drawing a spades, right? If the first card was a 4 of diamonds. So you need to ask yourself, right? If you want spades, you used to have 52 cards, and there are 13 of them, right? Does this affect either number? It will for sure affect the total, right? Does the diamonds affect my spades at all? Nope. So this is 13 over 51. That's what I would be after there. The probability of drawing a face card if the first one was a queen of spades, right? So probability of face, again, 52 cards. There are 12 face cards, right? This will definitely be affected because you're not returning it. The queen of spades, does it affect my face cards? Yeah. So it's 11 over 51. Okay, so try to figure out a method to make sense of it, right? Everybody has a different way of approaching things, so I can't give you like a formula that works every time. So drawing a black card if the first one was a king of spades. So, okay. So we have 52 cards. We lose one for sure, not being replaced. Black cards, there are 26. Would this be affecting the number of black cards? Spades is a black card, right? Black card. So we go -1, right? It affects both. So it's 25 over 51 like that. Okay. D, the probability of drawing a blackjack if the first card was a blackjack, right? So the probability here is 52 -1 for sure. There are 2 blackjacks, right? We already drew the same one, so we're down to 1 over 51. Okay? So there we go. That's page 51. Let's keep going. So if you get them all right, hey, that means that you're either very smart or I'm a really good teacher. Probably you're smart. That's what it is. The probability of drawing a red face card if the first one was a red jack, right? So RF, maybe save some time. So 52 -1 because we're not replacing. Always read carefully. Red face cards, there are 6 of them. A red jack would be a face card, right? And it would also be red, so it affects it for sure. If it had been a black jack, it would not affect the red face card. So read carefully. Okay, there we go. The probability of an ace if there was a king of diamonds. So 52 -1. Is the number of aces affected by a king of diamonds? It's not affected, right? Ace is the first number there. Okay. So let's keep going. The probability of drawing a queen if the first one was a queen of clubs. So 52 -1, queen of clubs, right? How many queens? Except for at home, I only have 1. Anyways, I did that one already, right? Yeah. Drawing a queen minus queen of clubs, right? So you're down to 3 over 51. Okay. There we go. And I think this one is exactly the same style, right? This is just worded differently. That's why I threw it in there. Okay, so there's standard deck of cards. The first one was a face card. Did not put it back. Very important, right? Dependent because of that. What's the probability of second card being an ace? So probability of ace in this case, right? 52 minus 1. And the face card was the first one, so that doesn't change. So it's 4 over 51. Done. Okay. I'll do the marbles, and then basically everything after that for a while is just review from different textbooks. So I would encourage you to do those because it's not me wording it. It's like another way of wording it. And so then you're prepared for anything I throw at you. Okay. And that will mix up odds. It will mix up probability. It just has everything. Elizabeth works at daycare. So here's the main important part. We have 45 marbles or beads, right? Or necklaces, sorry. 45 total. I'm just going to say that. Okay, so I have my key ready here so that I can be a little quick here. 45 total. What's the probability that a randomly chosen bead will be white? So this is just 45, and we have 18 whites. So this is what we've been doing all along. There's just one event, no big deal here. But then it's building. If the first one was a white bead, not replaced, I know what this is saying, right? What's the probability of second bead being white? In this case, the first one is removed, right? So we are down to 14. Oh, sorry, 45. 45 minus 1, my bad. We used to have 18 white. We lose a white one, so this is 17 over 44. That's what you're after there. The first one was a white one, not replaced. What's the probability of the second one being a blue marble? 45 minus 1 for sure. That is a guarantee that the denominator will be affected. And so if it's blue, we have 12. The first one was white, doesn't affect it, so it's just 12 over 44. Okay. You can reduce that to 3 over 11, right? 4 goes into both of them. Or 3 over 11. Okay. From the original bag, a white bead is drawn, a blue bead is drawn. Both have not been replaced, so it's a probability of the third one being red, right? It's a probability of red. 45 minus 1 minus 1. And so I had, at the very beginning, I had 15 reds. The first one was white, the second one was a blue one, so my reds have not been affected, okay? So 15 over 43. There we go. So read carefully, and you shall succeed. You will only learn math by doing math, right? It says it big there. You will only learn math by doing math. It helps to watch me do it, right? If you're not here, if you're not watching the lesson, of course, you're already at a disadvantage. But okay, so I haven't posted the key for this, and I'm still working through the whole thing, but here it is. So flip with me to page 54. And I basically just made a note for me here. Review. I'm just going to say pages 54 all the way to 68. Would I expect you to do every single one? Probably not. I mean, I know that there will be a few in here that will, and you will see the difference. You will see the difference if you do that. So this is reviewing probabilities, odds, all of that stuff. And if you find something that's a little bit too easy for you, just skip it, right? Just keep going. I left you tons of space, so it seems like it's a lot of work, but a lot of them are just put down the fraction and keep going, right? And I will work through this myself and post the key by, I don't know, sometime before 3:30 today, and you can check your answers, all right?